Good afternoon. Welcome to Dynamic Engineers videotape training session on DR ceramic filters, dielectric resonator ceramic filters. Basically, ceramic filters have been around over the last 30 years, starting with research projects. And as the 90s came about and the pressure to reduce the size of cell phones was very high, it generated a lot of R&D activity in the areas of ceramics because ceramics as a material is inherently stable over operating temperature and different other environments. So much research was done, and they realized that they could come up with ceramic-based resonators that had very high Q and could basically be manufactured in such a way that all the different filter synthesis topologies, Chebyshev, Butterworth, Bessel functions, all the different theoretical filter topologies could be realized using ceramic filter technology, which they could manufacture in much, much smaller footprints at a very high Q, very high selectivity. Ceramic material can handle up to 200 watts of power. So basically, the DR ceramic filter began to show up in large volumes, first in the cellular base stations, and then that technology, as it got more mature and got shrunk smaller and smaller, started to show up in your early generations of cellular phones. So DR ceramic filters is another filter specialty category that Dynamic Engineers promotes, sales and engineering. It's a separate factory, separate technology from the crystal and LC filter technology type. Ceramic filters can go anywhere from very low frequency, below 100 megahertz, all the way up to as high as 6 gigahertz. They tend to be used primarily as bandpass filters just before the antenna circuitry to transmit the carrier frequency out in the RF filter portion of your RF system block diagram. Again, many watts. So your customer talking about many watts going through a filter, depending on the detailed parameters, you may talk them into an LC filter, but if there's too much size pressure, they might end up going with some sort of ceramic filter. Again, ceramic filters like LC filters, like crystal filters, all custom designs, all customers are different. So therefore we give you 10 representative design examples, different package sizes, 13 by 12 millimeter, 22 by 12 millimeter, 43 by 13 millimeter. Again, the complexity internal to the ceramic filter is similar to other filter types. How many resonators you need inside the ceramic filter will be a function of the relationship between the pass band and the stop band. What is the insertion loss you need? How about the ripple? All of that will drive the size of the motherboard in an SMD simply because you need so many resonators to get the right filter profile, the pass band profile. The filter response curve, if you will. One specific example of success I want to talk about, because this could involve customers across the US in many different industries, is the wireless data module. Right now there's a movement in all over the world on factory floors that manufacture any types of technology you can imagine. All of the equipment, all the machines that are doing a particular process in manufacturing a particular product. All the machines on the factory floor 20 years ago were all connected with bulky cables. So the data communications from one machine transferred to the data communications of another machine via cable networks, laying along the floor, built into the ground, running in the ceiling. Nowadays, all of that cabling is being replaced with different types of wireless data standards like Wi-Fi. These Wi-Fi modules, these data modules, all must transmit their data under FCC regulations, specifically with respect to EMI radiation. These modules must reject out-of-band different application frequencies fairly aggressively. And the way these modules are doing it is they're pumping 1, 2, or 3 watts through a ceramic filter just before they get to the power amplifier to screen out all the unwanted radio frequencies that they may interfere with. So ceramic filters, we have a particular product that's qualified in with one of these wireless data modules at 2437 megahertz. It's going to go into tens of thousands of different modules that this company is making for a particular line. And they have multiple wireless data module technologies that they supply. They all need similar types of ceramic filters for their RF filter solution. So, depending on the type of requirements, Dynamic Engineers can be very competitive in this space for pretty large companies in terms of wireless data modules. And again, it's mainly to be a bandpass filter, to filter out all the unwanted frequencies around your transmit frequency. Some of the networks, what they do is they use the ceramic filters in order to selectively frequency hop. So when they're trying to transmit their data, they're doing it at different frequencies. But in doing that, by frequency hopping, and I'm not going to get into the theory of this, but by frequency hopping in their data transmission, they dramatically reduce the emitted radiation, the interference with other kinds of technologies that may be nearby their machines. So machine-to-machine wireless data modules use ceramic filters, and we have success in that area. And again, different type of animal compared to a crystal or LC filter, different types of pricing ranges. We'll get into that off video on a case-by-case basis so that you get a general idea. But again, all our crystal factories, ISO 9000 certified, selling to the highest reliability type customers, military customers if needed, tremendous process controls, great lot-to-lot traceability, and the whole filter product portfolio, in my judgment, represents Dynamic Engineers' strongest set of products in terms of percentage of wins. If you brought in all the RFQs, and what percentage of our RFQs do we become qualified on and win orders? I know for a fact, that our percentage of success is higher for filter products than any other products. A lot of that due to price competition, but the performance. We can provide very stringent performance criteria at good prices. That's why we're winning a lot of RFQs. So with that said, good luck. I've now discussed every portion of the product brochure, and I will make a few comments about the general product brochure after this segment. Thank you very much.